Take a look at a car that has been sitting under the sun for years. The surface that once reflected light like glass is now dull, chalky, almost powder-like. Run your fingers across it and it feels dry, rough, lifeless. Most people see this and come to the same conclusion instantly. The paint is dead. And when something is dead, the only logical solution seems to be replacement, sanding it down, repainting, spending thousands of dollars to start over. But what if that assumption is wrong? What if nothing actually died at all? There is a liquid that costs around $3, available in ordinary hardware stores, that can make that same surface look factory new again. No machines, no spray booths, no professional skills required, and more importantly, it doesn't work by covering up the damage. It works by interacting with the material itself. So here's the uncomfortable question. If a solution this simple exists, why is it almost never part of the conversation? In any system, there is always a gap between what works best and what gets recommended most. And when those two don't align, information doesn't disappear. It just becomes harder to see. Maybe the paint was never dead. Maybe we were just taught to see it that way. To understand why this works, we need to stop thinking of paint as color and start seeing it as material science. Modern automotive paint is protected by a clear coat, a transparent polymer layer designed to absorb environmental damage. Over time, ultraviolet radiation from sunlight begins to break down this polymer at a microscopic level, but it doesn't remove it. It doesn't kill it. What it actually does is fracture it. Under magnification, oxidized paint doesn't look smooth. It looks like a network of tiny cracks and channels. These microchannels scatter light in every direction, which is why the surface appears dull and chalky instead of glossy. The shine isn't gone, it's just being disrupted. Now here's where the $3 liquid changes everything. A properly formulated acrylic copolymer solution has extremely low viscosity. When applied, its solvent phase temporarily opens those microchannels. Then, driven by capillary action, the same force that pulls water through plant tissue, the liquid flows deep into the damaged structure. As the solvent evaporates, the resin begins to cross-link, forming new polymer bonds inside those fractures. Not on top of the surface, but within it. This isn't polishing, this isn't coating, it's structural restoration at the molecular level. This idea of restoring damaged coatings from within isn't new. In fact, it dates back more than a century. In the early 1900s, industrial chemists in Europe were already experimenting with thinned resin solutions to preserve large metal structures. Railways, in particular, faced a constant problem. Locomotives exposed to harsh weather would degrade quickly, and repainting them was expensive and disruptive. So instead of replacing the coating, they focused on restoring it. They discovered that low-viscosity resin could penetrate damaged lacquer, filling microscopic fractures and bringing back both structural integrity and visual depth. For railway systems, this made perfect sense. Their goal wasn't to generate repeat service, it was to maximize durability and minimize downtime. But as the automotive industry expanded, especially in the United States, a different system emerged. Cars became consumer products, not long-term infrastructure. The economic model shifted toward continuous maintenance, repeat services, and predictable degradation cycles. So the same underlying problem, surface oxidation, was approached in two completely different ways. One system optimized for longevity, the other optimized for recurring revenue. This is the key insight. Technologies don't disappear because they fail. They disappear when they don't fit the incentives of the system they exist in. And once that happens, the knowledge doesn't vanish. It just stops being passed on. To understand why this method isn't widely known, you have to stop looking at chemistry and start looking at economics. The auto body industry doesn't rely on major accidents to survive. Those are unpredictable. The real money comes from something much more consistent. Cosmetic deterioration, faded paint, oxidation, loss of gloss, small problems that happen to almost every vehicle over time. These are what systems thinkers call high-frequency, low-severity problems, individually minor, but collectively massive in revenue. Now, consider what happens if a solution enters the system with 4 specific traits. It's extremely cheap, requires no specialized tools, needs no professional skill, and only has to be applied once. That kind of solution doesn't just compete with the industry, it breaks the foundation it's built on. Because the current model depends on repetition, it depends on customers returning, it depends on the belief that restoration requires expertise and equipment. Here's the critical point. No one needs to actively hide a better solution. If it doesn't support the system's incentives, it simply won't be taught, promoted, or distributed. Over time, what remains visible isn't what works best, it's what fits the system best. When you compare restoration methods side by side, a clear pattern begins to emerge, not just in results, but in how those results are perceived. In controlled tests on oxidized automotive surfaces, acrylic-based resin treatments have shown the ability to recover a significant portion of original gloss, often above 80%, with effects that remain stable over long periods. In contrast, traditional polishing compounds, which rely on abrasion and surface fillers, typically deliver much lower recovery and degrade relatively quickly under real-world conditions. But here's where things become interesting. Most people don't evaluate results over months or years. They evaluate them in minutes. Abrasive compounds create an immediate visual transformation. The surface looks darker, shinier, more reflective, almost instantly. It feels like a solution, but that effect is largely superficial, dependent on temporary fillers and the removal of material. Over time, exposure to sunlight and weather reverses those gains. Resin-based restoration works differently. It may appear less dramatic at first, but it builds stability from within the material itself. The improvement is structural, not cosmetic, and that difference only becomes obvious over time. This reveals a deeper system dynamic. People trust what changes fast, even if it doesn't last, and systems are often built around that bias. Once you understand how the products work, a pattern begins to emerge, not just in chemistry, but in behavior. It starts with oxidation. The surface fades, loses gloss, and feels rough. The car owner looks for a solution and finds a product designed to restore shine. They apply it, and within minutes, the surface looks dramatically better. Problem solved, or so it seems. But weeks later, the gloss begins to fade again. The same chalky appearance returns. So the process repeats. Another product, another application, another temporary result. This creates a loop. Damage, quick fix, short-term improvement, failure, repeat. From a systems perspective, this is not random. It's a self-reinforcing cycle built around predictable behavior. The user experiences just enough success to believe in the method, but not enough durability to escape the cycle. Over time, something else happens. The user loses confidence in do-it-yourself solutions entirely. When the problem returns again, and it will, they no longer look for another product. They look for a professional, and that's where the system completes itself. Because the most effective system isn't the one that solves the problem once. It's the one that ensures the problem keeps coming back. Understanding the science is one thing. Applying it correctly is what determines whether it works or fails completely. The first step is preparation, and this is where most people go wrong. The surface must be completely free of wax, silicone, or any residue. These substances create a barrier that prevents the resin from penetrating the microchannels. That's why using a basic degreasing soap is critical, not to clean the car, but to expose the true condition of the paint. Next comes application. The resin should be applied in thin, controlled layers using a foam pad or soft applicator. As it spreads, it may appear cloudy or milky. This is not a defect. It's a sign that the solvent is actively interacting with the oxidized structure. Then comes the most overlooked step, time. The material needs time to settle, to evaporate, and to form new polymer bonds. Rushing this process interrupts the cross-linking phase, weakening the entire effect. In more severe cases, multiple layers may be required, each building on the previous one. This is not about force. It's about alignment with the material's behavior, because when you understand how a system works, you don't fight it. You work with it. At this point, the question is no longer just about car paint. It's about how systems shape what we believe is possible. We started with a simple assumption, that oxidized paint is dead and must be replaced. But what we discovered is that the material was never gone. It was misunderstood. And once you see that, something bigger becomes clear. In many industries, the most visible solutions are not always the most effective ones. They are the ones that fit the system, the ones that support repeat transactions, specialized services, and ongoing dependence. Meanwhile, simpler, more efficient solutions often remain at the edges, not because they don't work, but because they don't align with how the system sustains itself. This doesn't require a conspiracy. It only requires incentives. And once you understand that, you start to see patterns everywhere. Problems that seem permanent, solutions that seem expensive, assumptions that go unquestioned. The goal of hidden systems isn't just to show you a cheaper way to fix something. It's to help you recognize when a problem has been framed in a way that benefits the system, not you. Because sometimes the most powerful shift isn't in what you do, it's in how you see.